Orbital refueling is SpaceX's biggest technical nightmare. Landing Starship on the Moon requires multiple vehicles to rendezvous in orbit, transfer thousands of tons of propellant, and do it reliably every single time. One failure means the entire Artemis 3 mission collapses. So, how is SpaceX solving this? The answer just emerged from Starbase. SpaceX completed testing a depot power module and activated a hardware-in-the-loop testbed using actual flight hardware. What makes this solution so revolutionary that it caught NASA completely off guard? Here's the truth nobody wants to admit. SpaceX isn't just building a rocket to the moon. They're attempting something that's never been done before, refueling a spacecraft in orbit with cryogenic propellants at temperatures of negative 297 degrees Fahrenheit. The physics alone are brutal. Propellant evaporates, tanks experience thermal stress, and docking mechanisms must align within millimeters, while both vehicles are traveling at 17,500 miles per hour. NASA has watched companies promise orbital refueling for decades. Every single one failed. So why is SpaceX different this time? The answer lies in what's happening right now at Starbase. While most people focused on Starship test flights, SpaceX quietly completed a depot power module demonstration. This wasn't some PowerPoint presentation. They built actual hardware, tested electrical power generation and distribution systems designed specifically for a propellant depot variant of Starship. Then they went further. SpaceX activated a hardware-in-the-loop test bed using flight representative components. Translation: they're simulating real mission conditions with the actual equipment that will fly in space. This is how you turn theory into reality. But here's where the timeline gets terrifying. NASA's contract requires SpaceX to land an uncrewed Starship HLS on the Moon before the end of 2026. Not 2027. Not when it's ready. Late 2026. That's barely 12 months away. To make that deadline, SpaceX must prove orbital refueling works by mid-2026, giving them just enough margin to fix problems before the lunar mission launches. The window is closing fast, and the pressure just intensified. Internal documents suggest SpaceX might only manage an uncrewed Starship mission in 2027, with the first crewed flight slipping to 2028. Those assessments triggered alarm bells across NASA. Political pressure is mounting. International competition is heating up. The agency cannot afford another delay. That's why NASA introduced competition for the Artemis 3 lander role, sending an unmistakable message to SpaceX. Prove it works, or we'll find someone who can. This brings us to the real brilliance of SpaceX's solution. Instead of trying to refuel Starship during a single mission, they're building a permanent propellant depot in orbit. Think of it as a gas station in space. Tanker Starships launch from Earth, rendezvous with the depot, transfer propellant, and return home. The depot stores fuel until a lunar Starship arrives, tops off its tanks, and heads to the Moon. This approach eliminates the need for perfect timing on every mission and allows SpaceX to stockpile propellant over multiple launches. The technical challenges are staggering. Each lunar mission could require a dozen or more refueling flights. That's not a typo. Starship burns through propellant so quickly that reaching the Moon with meaningful payload demands multiple tanker launches. The choreography must be flawless. Launch schedules, rendezvous operations, fluid transfer rates, boil-off management, every variable compounds the complexity. One mistake anywhere in the chain breaks the entire mission. Yet SpaceX is charging ahead. Flight 12 is scheduled for late January or early February, validating the extensive V3 upgrades. These improvements directly support orbital refueling. Better heat shields mean longer on-orbit duration. Improved engines provide finer control during rendezvous. Enhanced catch hardware enables rapid turnaround between tanker flights. Every upgrade serves the larger goal. If Flight 12 succeeds, the entire schedule accelerates. If it fails, timelines compress dangerously. Meanwhile, infrastructure is expanding at a pace that would make other aerospace companies dizzy. Pad 2 at Starbase is nearly ready for V3 operations. Pad 1 needs upgrades to support two-stage landing operations and should return to service in the second half of 2026. Launch Complex 39A in Florida is being modified for higher cadence. SLC-37 is under construction, targeting 2027 operations. This isn't just about having more launch pads. It's about creating the distributed infrastructure needed to sustain the refueling flights that make lunar missions possible. Production capacity is equally critical. The Star Factory is reaching full operational capacity in 2026, becoming the world's first mass production facility for orbital-class rockets. The new Gigabay is under construction, expected operational around Q2. Combined with the two existing megabays, SpaceX will assemble multiple Starships in parallel. Why does this matter? Because orbital refueling demands volume. Lots of it. Building one Starship every few months won't cut it. SpaceX needs dozens of vehicles flying constantly to make the depot concept work. Then came the bombshell from the White House, a new executive order titled Ensuring American Space Superiority reset the entire timeline. The Artemis 3 crewed lunar landing is now officially targeted for 2028, not 2027. At first glance, this looks like a delay, a failure. But look closer at Elon Musk's reaction. He simply commented, "Cool." Not frustrated, not disappointed. Cool. What does he know that we don't? The answer reveals the real chess game being played. By shifting the deadline to 2028, the White House just gave SpaceX exactly what it needed. More time to perfect orbital refueling, more time to validate the depot systems, more time to conduct the uncrewed HLS mission in 2027, and analyze the data before putting astronauts on board. The revised schedule transforms from a crushing impossibility into an achievable challenge. SpaceX can now target an uncrewed landing in early 2027, review the results, fix any issues, and launch the crewed mission by mid-2028 with confidence. But the executive order didn't stop there. It outlined something even more audacious. The United States will establish the initial elements of a permanent lunar outpost by 2030. Read that again. A functional moon base just 2 years after the first crewed landing. Using traditional methods, that timeline is fantasy. Modules built on Earth, launched separately, landed individually, assembled on the surface. It would take a decade, minimum, unless you use Starship differently. One concept gaining serious traction is converting a Starship itself into the lunar base. Outfit the vehicle on Earth with expanded life support, habitation modules, and research equipment. Launch it to the moon as a standard mission. Then transition it into a permanent horizontal habitat using controlled landing techniques or cushioning systems. Suddenly, you've got a massive pressurized base delivered in a single mission. Even if that specific approach doesn't work, Starship's unmatched payload capacity makes it the only vehicle capable of delivering the heavy modules and equipment needed to build a base on that aggressive timeline. The strategic implications are profound. China publicly stated its intention to land humans on the moon by 2030. By establishing a permanent base that same year, the United States doesn't just visit the moon, it stays there. That's the difference between symbolic achievement and actual leadership. Early success buys time to select landing sites, build infrastructure, conduct extended research, and gain operational experience before China even arrives. This is why orbital refueling isn't just a technical milestone, it's the keystone of America's entire lunar strategy. Without it, Starship can't reach the moon. Without Starship reaching the moon, there's no Artemis 3. Without Artemis 3, there's no permanent base. Without a permanent base, the United States cedes leadership in space to China. Everything hinges on SpaceX solving this problem, and based on the hardware tests, the infrastructure expansion, and the revised timeline, they're not just attempting it, they're actually pulling it off. The depot power module works, the test bed is operational, the production facilities are scaling, the launch pads are multiplying. Every piece is falling into place. The next 6 months will determine everything. Flight 12 launches in late January or early February, validating V3 systems critical for orbital operations. By mid-2026, SpaceX must demonstrate actual propellant transfer between 2 starships in orbit. By late 2026, an uncrewed Starship HLS must land on the moon. Miss any of these milestones, and the entire Artemis architecture collapses. The pressure is absolutely brutal, but here's what makes this moment different from every previous promise about orbital refueling. SpaceX isn't talking about it anymore. They're building it. The depot power module is tested. The hardware and the loop systems are running. B-19 is stacking faster than any booster in history, potentially completed before December 24th. The Star Factory is reaching full production capacity. Every signal points to a company that's done experimenting and started executing. Meanwhile, Europe just took a significant step forward. Ariane 6 successfully launched on December 17th, deploying 2 Galileo navigation satellites and restoring European launch. Independence after years of relying on SpaceX. It's the rocket's 4th success in 5 flights this year. But let's be honest about the gap. While Ariane 6 celebrates launching twice in 1 year, SpaceX is preparing to launch multiple Starships per month to enable orbital refueling. The difference in capability and cadence is staggering. This is the race that matters. Not just reaching the moon, but staying there. Not just symbolic landings, but permanent infrastructure. Not just beating China, but establishing the foundation for Mars missions that come next. Orbital refueling is the technology that unlocks all of it. SpaceX either solves this problem in 2026, or America's entire lunar strategy falls apart. What's your take on SpaceX's orbital refueling solution? Do you think they'll hit the 2026 deadline? Drop your thoughts in the comments below. And if you want to follow every critical development as SpaceX races toward the moon, hit that subscribe button and turn on notifications for new space review. This story is just getting started, and you won't want to miss what happens next.